Good morning students. Today we can see about manufacturing technology first lab. Okay, so it will mainly deals with lathe machine where you will be going for phasing, turning, step turning, chamfering and knurling. Okay, so we will be handling about 4 processes at the single time. Okay, so we will be carrying out phasing. What is the purpose of the phasing is to make the surface clear or to make the surface plane, and next is turning where you will be reducing the diameter, and again coming to step turning where you will be cutting steps like this. Okay, so this is one sample specimen. So here you can see that cuts has been made as steps. Okay, and again after that you will be carrying out knurling. Knurling is for gripping purpose. Okay, so if I want to grip or if I want to hold this particular area and for a particular operation, what I will be doing means I will be making the particular surface a bit rough so that I can grip the particular specimen for the operation. Okay, so we will be carrying out knurling also. Then chamfering will be done. Chamfering is cutting an angular cut. Okay, so make an angular part, and so we can speak about lathe. So as we have seen in the theory class, lathe is the mother of all machines. Okay, so it mainly has a headstock, a tailstock and a carriage or a tool post. Okay, so the headstock is the part where you will be having the chuck and the spindle. Okay, so a motor will be there and you will be having a chuck for holding the work specimen, and this particular chuck will be rotating. Coming to the chuck, based on the jaws, we can classify into 2 types, or we can say it as 3-jaw chuck and 4-jaw chuck, and here we are using 3-jaw chuck. So here the centering will be done automatically, so it is not a tedious process when it comes to 3-jaw chuck, but when it comes to 4-jaw chuck, the centering itself is a big or is a tedious work, and it is mainly carried out for irregular shapes and all. We can go for 4-jaw chuck. Okay, and next is the tailstock. So the main purpose of tailstock is for centering, and you can say like drilling you can carry out. So you are having a drilling bit like this, and you can put it inside the tailstock, and then you can give the feed by moving the tailstock. So what happens means the particular specimen will be rotating here, and you will be bringing the tool to nearby and carrying out the cutting process. And apart from drilling, you can again go for reaming work. Okay, reaming can also be done with the help of tailstock. Okay, and if you are having a long specimen or like a long tube or a long rod in which you have to carry out the process, the tailstock will be acting as a support. Okay, so these are some of the main applications of tailstock. And then coming to the major part, that is the tool post. Tool post is the area which rests on the gateways. Okay, so you will be having a gateway above which you will be having the carriage, and you will be having tool post. In the tool post you will be keeping tools like this. Okay, like this. So single point cutting tool like this will be used, or you will be keeping it over here, and you will be bringing it towards the specimen. Okay, you will be bringing it towards the specimen. So if it is a turning process, the feed will be parallel to the axis of the specimen, and if it is facing process, it will be like this. Okay, perpendicular. So these are some of the main steps in phasing and turning, and apart from that you can carry out other operations like knurling, boring, drilling, reaming. For example, you are having knurled specimen. Okay, you are having knurled specimen here. So this is for the gripping, ease of gripping. Okay, and the tool which you will be using for knurling will be like this. Okay, you will be having a rotating tool with patterns, and you will be keeping it in the tool post and allowing the material tool to touch the particular rod specimen. So what happens means this pattern gets engraved in this particular specimen. Okay, that is what happening in knurling process, while in boring you will be having tools like this. So what you will be doing means you will be allowing the material or allowing the tool to go inside the particular material, and then you will be giving the feed. Automatically cutting off the hole or enlarging the hole happens in the boring operation. And apart from this, you can go for operations like taper turning. So here you will be keeping the or you will be providing an angle for the cutting tool based on which you will be giving the taper turning, and thread cutting also can be done with the help of your lathe machine. So these are some of the main applications of lathe. Okay, like to start with turning, facing, taper turning, knurling, boring, drilling, reaming, again you can cut the specimen in two parts. Okay, these are then grooving can be done. Okay, these are some of the applications of lathe, and after this we can see how a lathe work. So now we can go into the practicals. So this is the specimen which we will be giving to the students. Okay, so to check with the length, it is about, we are using a vernier calipers to check with the length, and it's about like 94. Okay, it's like 94 mm, and the diameter is about 20. And what we will be doing here means we will be going for a facing operation and reducing the length to 90 mm, and again turning operation and reducing the length to like 18 mm, and after that we will be going for step cutting. Okay, so we will be having an 18 mm and a 16 mm. Okay, one step cutting will be carried out, and at the end part we will be going for a chambering operation, and at the other part where you are having 18 mm you will be going for a knurling operation. Okay, so this is what we are going to do in this particular experiment. So Mr. Rajendran will be helping us to carry out the experiments. So he is fixing the specimen inside the jaws. Since it is a 3-jaw chuck, we are not in need of the surface. We don't want to check the surface, okay, since it is a 3-jaw chuck, because automatic centering will be carried out in 3-jaw chuck, while if it is for a 4-jaw chuck means automatically we have to carry it out, the centering has to be carried out. So the fixing of the single point tool is done. So first we are going to start with the facing operation. For that he is going to the center or bringing to the center of the specimen. So the first, the rough surfacing or rough facing is carried out. When it comes to lathe, the main process parameters is speed, feed and depth of cut. The speed is provided by the rotation of chuck, and feed and depth of cut is provided over the carriage part or the movement of the tool post, you can say like that. In order to get a fine surface finish, the speed, the depth of cut as well as the feed rate should be minimal, okay, in order to get a good surface finish. While in order to get a maximum material removal rate, you can increase the depth of cut as well as the feed, but so as to get a good surface finish. So surface finish is required for certain applications. So in order to attain the good surface finish, you have to go for minimal depth of cut as well as minimal feed rate, okay. Okay. The facing operation has been carried out, and now we can see about the turning operation. So we are having a carriage traversing wheel, okay. So this is your carriage traversing wheel and this is your cross slide wheel. And for the turning operation, what you will be doing means you will be keeping the cross slide wheel at 0, okay. At the initial condition you will be keeping the cross slide wheel at 0, and then you will be using your traversing wheel to move or to give the feed. So your depth of cut will be given by your cross slide wheel and your feed will be provided with the help of your traversing wheel, okay. So here we can see the feed is provided with the aid of traversing, okay. With the aid of traversing wheel, sir is providing the feed. And the least count for cross slide wheel is 0.1 mm. So if you move 5 or 5 points means 0.5 mm cut will be provided, or depth of cut will be 0.5 mm. And coming to the feed or the traverse wheel, what happens means the least count is 0.2 mm. So if you give a change of 5 units, what happens means 1 mm movement will be happening. So the rough turning process has been completed. Now for step turning or step cutting, we are giving more depth of cut, okay. So that is the end of your experiment, okay. So we have carried out facing, turning in the lathe, okay. So that is the end of your experiment. Have a good day.